So let's talk the rest of the semester for this class. So today we're going to talk about logs again, because that's definitely going to be on your final. We'll refresh our memories from the 3 days that we had of logs before break. And then we're going to extend it. Today we're going to go into some applications. Fancy way of saying word problems. Okay? Tomorrow we're going to talk about inverses. Okay? And then Friday and Monday is going to be the review for your final. Okay? You'll get the final review packet tomorrow in class, and then Friday and Monday we'll be reviewing. So your final is, if you have me as a grading teacher, your final is Thursday, right away in the morning, which is, I think it's 7:50. It's not an 8 o'clock start. It's a 7:50. You had your half sheet. I think it's a 7:50. Yep, a 7:50 start. Okay, so that's a 7:50 a.m. in here, ready to go on your final. If you are a Roth grader, okay, then you're in here, period 3. You had to go period 1 and period 3 because it is, those are both 80-minute periods. I'll give you plenty of time to do this final, because this final is not Scantron. Okay? It is all short answer, meaning it's all, you got to do work, you got to show your work, you got to come up with the answers for it. Okay? You will need a calculator. Okay? You can take the chance that looks like there's 8 calculators up here that nobody else will, that you'll be one of the first 8 to get in the room. But I like to know that I got a calculator coming into it, because you do need one. Okay? And all of the topics from first semester are on the final. Okay? Your final is worth 20% of your semester grade. Okay? That's not a new thing, that's an NTC. All right? I think it's 16 questions. 15. You get a note sheet. Okay? You started it back in Unit 4 with the rational functions chapter, so you can fill in the back side or the rest of the front side on that. We will not be giving you any formulas. We will not be giving you any things like that. Okay? Any questions on that? Canvas is still wide open. No. NTC dictates that. We could have made it here for like 15 if we wanted to, but then your NTC grade is different than what you see in line. There were a couple of college classes where I only had 2 grades. All right, let's do this. So, a quick review of logs. Remember that this should be on your note sheet for sure. Going into next week, a week from tomorrow's final. Yes, this should definitely be on your note sheet. That if you have the base and an exponent, so if we have it in exponential form, base to a power equals argument, then to solve that, if the variable is in the exponent, we have to switch it into log form. Log base of the argument equals the exponent. That should 100% be on your note sheet. Okay? Going through. With that being said, okay, take a couple of minutes here and solve each of those for x. In the first one, my log is isolated. so I can then switch forms with it. 3 is my base. 4 is my exponent. X plus 5 is the argument. So there's the switch. 3 to the 4th power is 81. Subtract 5 from both sides. I get 76 is the answer. 76 plus 5 is 81. 3 to the 4th power is 81. Log base 3 of 81 is 4. Yes. Over here on this one, I don't have my exponential term isolated, so I've got to subtract first. That gets me 9 to the x plus 10 power equals 78. Now I've got it isolated, so now I can switch into logarithmic form with it. So if I switch into logarithmic form, then that would be log base 9 of 78 equals x plus 10. Log base 9 of 78. Going to be a little bit less than 2 because 9 squared is 81. I get 1.9828233637 equals x plus 10. Then I have to subtract 10 from that, and I get negative 8.017. If I plug that back in, negative 8.017, oops, that breaks, negative 8.017 plus 10 gets me 1.983. 9 raised to 1.983 power is 78.0 plus 3 gets me 81.0302316.5. Because I used the rounded one, that's why it's not exact. If I would use the exact one, it would be exact. Questions, comments, concerns, clarifications? All right. It is word problem time. Let's do it. Huh? So, the amount of toxic fumes measured in Stanky units, or SUs, left in the family truckster after a road trip to Florida can be modeled by F of H equals 2,000 times 0.087 to the H power, where H is the number of hours after you get to your destination. Okay? What kind of an equation do we have? What kind of an equation is that formula? Linear? Is it quadratic? Is it exponential? Is it logarithmic? Is it, why is it exponential? Variable is in the exponent, yes, so it is an exponential, okay? Because depending upon what kind of equation we have, that's going to depend on how we go about solving it when we get to solving stuff, okay? So, how many fumes are there in the vehicle when you get to your destination? What H value is that? What H value is when you get to your destination? No. What is H defined as?
Number of hours after you do.
So if we get to our destination, what's our H value?
0.
0. Okay? 0. Because that's when you get to your destination, H is 0. Okay? So if H is 0 for this particular subpart of the problem, how many Stanky units are left in your van?
No.
You guys have obviously never been on a road trip before. When you get to your destination, there's some Stanky units in your vehicle. What do we do? Why is it 2,000? So you're plugging in 0 for H into our formula? Anything to the 0 power is 1. 1 times 2,000 is 2,000. So there are 2,000 SUs in the Vanley Truckster when you get to your destination. How many Stanky unit fumes are in the vehicle 24 hours later? What do we have to do here now? Put 24 and find F of 24. Okay. Find me F of 24. We'll round it to 3. 3 decimal places. Anybody? Okay. If the human nose can't detect a smell with an SU value lower than 7.8, when will the vehicle return to its normal smell? Again, our function was F of H equals 2,000 times 0.87 to the H power. So we say what now? Equals to the 2,000. That one? Okay. Find me how many hours it takes for the van to return to its normal smell. What are we going to do first? Divide by 2,000. Then what? Which forms was it? Then we gotta use change of base formula, right? Log of 7.8 divided by 2,000 divided by log of 0.87 gives me 39.82978877. So how many hours? Okay. When a plant or animal dies, it stops acquiring carbon-14 from the atmosphere. Carbon-14 decays over time with a half-life of about 5,730 years. Note, this means it takes 5,730 years to lose half of its carbon-14. The percent P of the original amount of carbon-14 that remains in the sample after T years is given by that equation. P equals 100 times 1/2 to the T over 5,730. Okay? I also wrote that equation up on the side, or actually Mr. Roth wrote it up on the sideboard for you, so that we can scroll down and get the, I think it's 4 questions. All right, so we'll do 2 questions at a time. Okay? So what I want you to do is I want you to tell me what percent of the original carbon-14 remains after 5,730 years. What percent remains after 2,000 years? Find me those 2 values right now, please. So if you read the problem, you would know that this one is 50%. If you didn't read the problem and you plugged in 5,730 years into the percentage equation, you should have gotten 5,730 divided by 5,730 is 1. So then this becomes 100 times 1/2 to the first power, which is 100 times 1/2, which is 50. All right. Percentage on this one then. So then this one we don't know, so we're going to have to plug this one in. 1/2 to the 2,000 divided by 5,730. And that's going to give me, if I plug that in, 100 times 0.5 raised to the 2,000 divided by 5,730 should be bigger than 50%, and I get 78.510,62746. What was that? Are you putting the exponent in parentheses? Good times in between them. Now open another set of parentheses. Yep, now we'll go 2,000 divided by 5,730. So we'll call it 78.510. Oh, 511. Okay. Next 2. What percent of the original carbon-14 sample remains after 20,000 years? And when will the sample have 1% of the original carbon-14 remaining? again, on the sideboard is the formula. P equals 100 times 1/2 to the T over 5,730 pounds. So P here is going to equal 100 times 1/2 to the 20,000 divided by 5,730 power. And when you do that, you should get 8.8978377763. So we'll call that 8.898%. Agree with that one? Okay. Then, on this one, we've got 1 now is going to equal 100 times 1/2 to the T over 5,730 power. So I need to first divide by 100. So that's going to give me 1 over 100 equals 1/2 to the T over 5,730 power. Then I need to make it be a log or switch it into log form. So that's going to be log of 1/2 of 1/100 is going to equal T over 5,730. Log base 1/2 of 1/100 is 6.64385619. Then to solve it, I multiply by 5,730 on both sides. That gives me 38,069.29597. So we'll call that 38,069.296. This is going to be years. Questions on that? Yes. My guess is you didn't put parentheses around the 1/2. At 1 minute, just 0.01. You get 1 by a lot. Yeah. 1/100 is 0.01. Yep. Mm-hmm. Okay. Now, before we start this problem, this formula with those definitions should go in your notes, probably even go on your note sheet if you want to get this question right on the final. Okay? A equals P times the quantity 1 plus R over N to the NT power needs to go on your note sheet. A in there is the amount of whatever it is that you have. P is how many you started with. R is going to be your rate. Now I will tell you that your R is usually given to you in a percentage, and you need to convert it to a decimal. It's a percentage in the problem. You need to convert it to a decimal to use it in the formula. N is the number of times that whatever happens to it. Okay? If it's money in a bank account, it's the number of times that they apply the interest rate for you. If it's depreciation of a vehicle, it's December 31st going into January 1st, and when the clock strikes midnight, your vehicle is now one more year older. Okay? So you would apply that percentage rate one more time, and so on and so forth. Okay? And T is the amount of time. Whatever the time is given to you in the problem, that's the amount of time that it is. Typically, we're talking about within a year. So Mrs. Hoff searches the couches in her home for loose change and collects it. 1 year, she collected $207. She put this money into account for rainy days that pays 4% interest that is compounded monthly. Use that formula. So first off, we need to write a model to represent the money in her account. Okay? Well, the money in her account is going to be A. P is how much she started with. What did she start with? $207. So that's 207. 1 is 1. R, what is our interest rate? 4%, so that is what as a decimal? 0.04. N is the number of times that it is compounded. If it is compounded monthly, how many times per year would it be compounded?
12.
12. We don't know T. Okay? Does everybody have that formula written down? Okay? So with that being said then, here are 3 questions that I want you to answer based off of that formula. Oh, snap lap. So after 5 years, so then that's going to be A is going to equal 207 times 1 plus 0.04 divided by 12 to the 12 times 5 power. So that's 207 times 1 plus 0.05 It's me. I get 252 and 75 cents. Only rounding to 2 here because we're talking money. The only change is now instead of here it would be $176.80. There. Okay. How long until it has $1,000 in it? Again, this is assuming that you don't have any rainy days. 1,000 is going to equal 207. 1 plus 0.04 divided by 12 to the 12t power. You first divide by 207. Now I would leave that as 1,000 over 207. Just because, and I would leave this one like that, because then you're not dealing with a funky decimal or something like that, trying to type it in. Because you're just going to go to the calculator and type it in here on the next, on this next step. So now you're going to go log, and your base is going to be that of this, and that's going to equal 12t. So now when you go to the calculator, you got to make sure that you have parentheses upon parentheses upon parentheses, so that when you type it in, you get log of 1,000 divided by 207 equals on that one. Divide that by log of 1 plus open parentheses 0.04 divided by 12 close and close gets me here. This would be 473.29802772. That's going to equal 12t. Now when I divide both sides by 12, I get 39.44150227 is t. So we'll call this 39.44150227.